Hello, we are going to be talking about linear inequalities using word problems. Now, we tackled inequalities a while ago, and so this is just going to kind of be a review of that. Before when we did them just using one variable. So y is less than a line, or y is greater than a line, or y is less than or equal to a line, or y is greater than or equal to a line, but it was just one line, right? In this case, we're going to be looking at an inequality using two variables. But the process is pretty much the same. So when working with linear inequalities as word problems, before you can solve or graph them, it's important to be able to formulate them or to put them in math terms, given whatever situation you're given. So here is some steps that you might want to think about as you do this. Step one, break down each piece of the situation, and you're going to assign the appropriate coefficients to each variable, and you'll see what I mean. Then decide the appropriate inequality that represents the situation, and I've kind of given you some hints here. Like when we're talking about maximum, which is one of the words that we use, I want you to think about the ceiling. Like if you were to jump up, hopefully your head's not going to go through the ceiling. If all things are well, you're going to hit the ceiling and you're going to come back down. So maximum meaning the highest, that's your ceiling. Now, these are the words that you might see when we're talking about maximum. Now, this is just a guide. You're really going to have to play the movie in your head of the words and really use your experiences to kind of make sure that what you're formulating is correct. Then we've got, well, what if it's not less than or equal to? When something is less than, I've given you some words to kind of think about. It's fewer than something, or it's below something, or less than something, or under something. Now, when we talk about minimum, that's the lowest you can go. So I want you to think about the ground. You can stomp on the ground all you want. Unless there's a sinkhole, you're not going through it. That's the lowest you can go. So if we're talking about minimum, we can't go any less than that. We can't go any fewer than that. We can go at least. Then I want you to think about, what if something is greater? Well, then if it's greater, then it's above everything, right? So these are just some words that you can use. I'm not going to ask you to memorize them because I want you to be able to reason through what you're doing. It's just a guide. So let's go ahead and look at these three problems that we have and work through them. So the first one says Jessie is printing out copies of a presentation. It takes 5 minutes to print color copies and 1 minute to print black and white ones. Okay, so color, black and white. He wants to spend under 59 minutes on printing. So if he wants to spend under that, that means he doesn't want to spend 59. He can spend anything less than 59, but not 59 and not above 59. So we're going to write this inequality in standard form. Remember, ax plus by equals c. And we're using that to describe the situation. So if he wants to make 5 colored copies, we can put that as 5c. And he's also going to make black and white copies, and it's 1 minute to print black and white copies. But he wants to do that in under 59 minutes. That means that this portion has to be less than this. So we're going to face the inequality to the left. So it can be 58 minutes over here, 57, 56, anything less than 59. And of course, this would never be negative in a real world situation. So that's all you need to do on this. We're not asking you to solve anything, just formulate. So let's look at the second one. Sydney is knitting baby items to sell at a craft fair. She has a total of 1,250 yards of yarn to use for these items. A pair of booties uses 211 yards of yarn, and a cap uses 222 yards apiece. Write the inequality in standard form AX plus BY equals C that describes the situation. So what we know is that she's doing booties and she's doing caps. What we also know is that it's 211 yards of yarn for a pair of booties, and it's 222 yards of yarn for a cap. But what we also know is that she only has 1,250 yards of yarn. Now, in a real world situation, she could go up to the 1,250 and she can go under that, but she can't go above that because she wouldn't have any yarn left. So we know what's on the left side has to be less than or equal to what she has. All right, let's look at the last one. Hannah is selling handmade jewelry to earn money for camp. Bracelets sell for $6.53 and necklaces sell for $28.75. And she needs to make at least $630 in revenue, meaning money that's coming in to cover the cost of the camp. Write an inequality in standard form AX plus BY equals C that describes the situation. So $6.53 for the bracelets, $28.75 for the necklaces, and she needs to make $630 so that she can go to camp. That's the least amount of money that she can make. So what that tells me is that whatever she sells can be equal to the $630. If she makes less than that, she can't go. But there's nothing that says that she can't make more than that. So the left side, the money she brings in from the sale of the bracelets and the necklaces can always be greater than $630 or even equal to $630. It just can't be less. So that's why we're choosing the greater than or equal to sign. So I hope this has been helpful. If you have any questions, please let me know. Goodbye.